Fellow students and seekers of truth, let us continue our study of domain and range. And we'll start out by focusing on domain here. We'll talk about range in one of the later videos. So I want to find the domain of this function here. It's the square root of 4 minus x. And remember the rules. We're going to start out with all real numbers, and then we're just going to eliminate the ones that cause problems. Anything division by 0, that's not a problem here. There is nothing being divided, so you don't have to worry about division by 0. And anything that causes the square root of a negative, so that would be a problem here. You have a square root, so you could potentially have the square root of a negative number. So what that means is that for the inputs to work here, the inside of the square root, 4 minus x, must be a positive or a 0. It must be 0 or greater. There's no possible other way for this to work. If you put in a number that's very large, like 5, you're going to get 4 minus 5 equals negative 1. So that's going to be the square root of a negative number. So here, my solution here is not that difficult. I'm going to move x to the other side. So I'm going to get this result here, that 4 has to be greater than or equal to x, or x has to be less than or equal to 4. I'm going to write it in a slightly different way as well, in interval notation. This is basically saying, and I'm going to draw out a graph here. Let's say that this is the number 4. My solution set would be everything that is less than or equal to 4. So everything that goes this way. So in interval notation, that would be from negative infinity, exclusive, to positive 4, inclusive. So 3 different ways to represent the answer: as an inequality, as a graph, and as interval notation. Let us continue, and let's look at part B. So this problem is like the first one, except now we have a potential of division by 0. So one thing that we know already is that 4 has to be greater than or equal to x. Otherwise, you would have the square root of a negative number. But division by 0 is also a problem. Like, what values of x would cause the denominator here to be equal to 0? So we can solve the denominator for 0. And we could see then that we can factor this. This is going to end up being x minus 3, x plus 2 equals 0. So, let me get better. So then x minus 3 equals 0, and then x plus 2 equals 0. So when x is equal to negative 2, okay, or x is equal to 3, you have a problem. These numbers here are going to cause division by 0. Right? So x equals 3 and x equals negative 2, those numbers will cause division by 0. So that means those numbers are not part of the domain. So the domain is all numbers that are less than 4, but also numbers that are not equal to 3, and numbers that are not equal to negative 2. So these 3 statements together give us the domain. Now, writing it this way is technically correct, but kind of undesirable because it's hard to visualize and picture what that looks like. So let me represent it to you as a graph on a number line, and also as as interval notation. So let's see. I'm going to put 4 on there, right? And then I'm going to put 3 on here, and then I'm going to put negative 2 on here. So it's any number, x can be any number less than 4, so solid dot here, anything less than 4, but not equal to 3, so we're going to put a little hole right there. Can't be equal to 3, and it also can't be equal to negative 2. So any number that is to the left of negative 2, between negative 2 and 3, and between 3 and 4. So the final answer for this, I'm going to write it in interval notation because that's actually preferable, is going to be negative infinity to negative 2, in union with negative 2 to 3, in union with 3 to positive 4. And positive 4 gets a square bracket because it could be equal to positive 4. Okay? So there you go. That's an example here where you have potential of division by 0. And again, this way up here that we wrote earlier is technically correct, but it's way too complicated to make real sense of. It's easy. It's actually easier to look at this. You say, oh, asking you any numbers in here, any number in here, and any number in here. Or you can show this as a number